Hey, welcome back to the radio room. Doing a little work out here on an old amplifier. This thing's, well, it says amateur, but it's typically mid 70s through the 80s, probably mostly used on CB. Got it in here to take a look at it. The owner wanted to know if it was working or not, which it does. But I did want to show y'all something. These old amplifiers like this, well, they didn't always have a really clean signal on the output, and sometimes they got a little overmodulated, just the way they were driving afterwards, and I kind of wanted to show you this. And I don't have this set up quite exactly the way, I guess you could say it'd be professionally done, but by gosh, we're going to make it work. So I needed to be able to see what the modulation envelope looked like on the output of the amplifier, and I'll also give you a comparison with and without the amplifier. So we got the FT817. We're using that as our driver. I just have it on a frequency. It is running into a dummy load, which is sitting over there. Yeah, so I don't have a directional coupler to to couple my oscilloscope to the output of the amplifier or even the 817. So I had to get a little creative. What we're going to do is we're going to loosely couple the output. We just need to see what it is. This is not going to give us any absolute scientifically accurate measurements, but it is going to let us see what the envelope is on the transmit. So I'm going to try and run through this. I'm having to do this on my phone. I kind of rearranged things in my bench here. I did have all my test equipment over here. And as you can see, I got a camera that's sitting on top of that. That's the one I've normally used anytime I was using the oscilloscope. The oscilloscope was sitting right here. So it was just easy. I had a little stand that I put out here and I could view the oscilloscope. However, it doesn't quite make it over to the oscilloscopes now. So I'm having to do this on the phone. So please bear with me as I do this. It may get a little shaky. So let me show you what we got here. First off, I'm going to change the oscilloscope and show you that we do have a sine wave coming out. That is the 18.147 megahertz signal. This is a 40 megahertz oscilloscope, so it's not going to get too much resolution. I have the smallest time base there, and you can tell I'm on AM as I'm talking. You can actually see the envelope changing. So how did I get, without having a directional coupler in line with the feed line, how am I getting that into the oscilloscope? And this is kind of the trick I wanted to show you. Coax is great. It keeps and directs most of the energy to the antenna or wherever you happen to be sending it. But it does create a field around it that is exactly a reproduction of what's going through it. Let's just say it leaks out of the coax a little bit. So since I don't have anything to put here to run the coax through and pick off a little bit of RF to go into the oscilloscope, I obviously don't want to run this much wattage. That's 5 watts. Yeah, the oscilloscope might like it, but that's not going to tell me what's going on to a 50 ohm load. This is not a 50 ohm load. Radio very unhappy without 50 ohm load. So I want to loosely couple it. So right here is where I've got it loosely coupled. This coax is on the output of the amplifier. Right now I don't have the amplifier in the amplified position, so it's just running through the amplifier, which, by the way, I think I need to get in here and clean up some contacts on a relay, because in the bypass mode it doesn't seem like it's really wanting to play well. In fact, my radio doesn't like me when I do this. but that is SWR. You see it's going to SW. Well, that's a pretty high SWR. So we're just keeping our transmissions real low on that. In bypass, the SWR doesn't seem to be as bad when the amplifier is actually on. So this is how we're loosely coupling to it. I just have a wire, and this is probably 20 gauge, 22 gauge wire, multiple turns around the coax. And then I have my oscilloscope probe and oscilloscope ground hooked up to that. That's going to induce voltage, induce current, and therefore a voltage reading on the oscilloscope through here that I can pick off some RF that's leaking, so to speak, out of the coax. So let me just give you a little comparison here. So you know the amplifier does work. That's without the amplifier. That's with the amplifier. You can see it's just about going off the screen. So we know we do have power, and we know that we do have a change even in our loose coupling. But I wanted to show you something else as well. That was the RF that we had coming out. I want to know what the modulation looks like coming out of here. Well, I can't whistle worth a darn on a perfect note, so we're going to use a signal generator. Well, I haven't set up a cord or a patch cable that'll go directly into the radio, but the signal generator doesn't particularly like this. It likes a 50 ohm load, but I am going into that speaker. So I got 1,000 hertz tone. I got 2.5 volts peak to peak. And I'll turn this on for a moment. We're just going to audio couple through the microphone. Like I said, not super scientific. It's not going to give us a defined amount of audio frequency going into the radio. It's going to give us a comparison. So, if you can hear that, that's our 1,000 hertz tone. So what we're going to do is I'm going to go ahead and turn this back on. And we're going to look at this. First off, let me show you what it does if we're still just looking at the RF output. So that's just pretty much the same thing. But if we slow our time base down and we really stretch it out, we're doing 2 milliseconds or 0.2 milliseconds per division there. You can start to see that envelope. See that? That's that envelope. You can actually see my voice modulating it some too, but I'm just holding the microphone up to the speaker and getting that. So that's about 100% modulation right there. Now I want you to pay attention to right in between those. They just come down to 0 and they come right back up into a new envelope. Now let's take a look at it. I might have to increase my volts per division a little bit. Let's see what it does with the amplifier. Oh, see, that's not good. See those spaces in between the in between there? When it's fully modulated, that means it's over 100% modulation. There's actually a point where there's no RF coming out for an extended period of time. By extended, I mean milliseconds. But what's going on is, let me turn that off. I'm not sure how that's picking up on the camera, but that means it's actually over modulating. It's greater than 100% modulation that's coming out of there. What we want to see is something like that. And I can't hold the phone and change the triggering right now, so let me see if I can clear this up just a little bit. Well, that was the wrong way, wasn't it? Maybe I can prop this up. I'm not sure. Alright, give me just a second. I'm going to pause here for just a moment. Let me see if I can get this to trigger a little. Okay, so that's a lot clearer right there. You can see how they're just coming together. Now let me do it with the amplifier back on. You'll see how there's more of a gap in those pinch spots. It'll be over pinched. See that? That's not a good modulation envelope. So I just wanted to show you that. Sometimes you don't have to exactly the right tools on hand, but you can improvise. Using a signal generator, we're just audio coupling it. Now, one reason why I did do it that way through that is because I never changed the level on this, and I was holding the microphone in the same spot, the same orientation to the speaker. That's as close as I get for apples to apples between the two. And we have our loose coupling. I just call it loose coupling because we don't have a direct connection to the RF that's coming out, but we are getting enough induced into this to feed the oscilloscope. So I'm going to go ahead and take a look inside this amplifier. I want to take a look and see if maybe the relays are dirty, because we're in the bypass. That's a pretty high SWR. Let me find a different band here so you guys can. Okay, so that's S meter. See how that bumps up? That's SWR. That's not good. So that tells me that the input filtering, if there is any, on this probably isn't doing very good. That or the contacts through to bypass the amplifier circuit to just barefoot through the amplifier might be dirty or something. So yeah, these right here, best I can tell, I'm going to take a look in the inside. Might have another video to update this here in a little bit, but these don't have any output filtering either. So I might see if I can't get the tiny SA out, see if I can get it to read maybe my RF coming out of this, just, you know, with the antenna, the spectrum analyzer part of it. See how many spurs there are, see how wide the wide bandwidth is. I'll have to see if I can get the tiny SA to do that. Just got that not too long ago. Still playing with it and figuring out how everything works on it. So maybe we'll be able to see if there's any harmonics or spurious emissions coming out of this. Don't know. Like I said, still got to figure out the tiny SA. You know, real hams don't read manuals. Haha. So we'll find out on that. But I really don't like how it's got better than 100% modulation coming out of the amplifier, especially when we had 100% or looked like maybe 90% modulation just coming straight out of the 817. That tells me, and I haven't found hardly any information on this amplifier, but it tells me that this is not a very linear, even though it says bilinear, it's not a very linear amplifier. It could also have some problems with the filtering coming into it, producing harmonics before it even gets amplified, which would be even worse because it'd be amplifying those spurious emissions if they're getting, if it's not coupling right in here. So we'll see what happens. But these, it says amateur right here. This thing's supposed to work anywhere from, I think, 3 to 30 megahertz with little information I found. But there's no output filtering. I mean, there's no band selection on this. There's no way to tune that final output. I'm not even sure it has a low-pass filter in it, to tell you the truth. So this thing could be transmitting on, in this case, we were at 7.4. I think we were at 18 something earlier. It could have had harmonics at 34 or 36, 37 megahertz, maybe even up 74 megahertz. It could have still had spurious emissions coming out of that. So I just kind of wanted to show y'all what was going on here in the radio room right now. Still working on getting everything set up a little bit better out here on the workbench. Like I said, moved some stuff around, got all the the equipment actually in a little bit better spot to work with. When everything was over here, that was a long way for leads, and scope probes and stuff were barely making it over here when I was actually working on something. So the whole radio room is, well, it's constantly changing. Some point in time, this whole area will probably be rebuilt to let the more room for the test equipment, tools, and specifically so that I have a bigger area here to work on a lot bigger equipment. Those of y'all familiar with an 817, you can kind of see it's a little crowded right there. So just wanted to show you what was going on. Some of the guys from the club had heard me talking about some stuff earlier this evening on the net. The Mad Scientist Lab is what I was talking about it as. Having to do some improvising and some innovation to try and get the readings I needed to see on the oscilloscope. Hopefully this kind of explained what was going on with that. So until next time, just a little update from the radio room. We'll see you later.